Hello everyone, welcome to my channel. I'm Riyansh Gandhi and today we're going to be solving advanced problems with basic concepts. So what are we looking at today? We're going to be taking a look at geometric probability. So what is geometric probability? Geometric probability is the process of solving for a probability which cannot be counted. Now this might seem weird, like what does that even mean? And we'll get to it when you see an example. A common technique is to draw figures to represent the probability. So the formula for geometric probability is that given a region A inside another region S, the probability that a randomly selected point in S is also in A is given by the area of A divided by the area of S. Now, just before we dive into our examples, I'm just going to leave a note that sometimes geometric probability can involve concepts from just regular probability, as seen in the final example. So, now let's take a look at some few examples. So this is our easy example. A square target has a side length of 16 inches. So we know then that this side length is 16. In the center of a target is a smaller square as shown. So this is the smaller square with a side length of 4 inches. If a dart randomly hits within the larger square, what is the probability that it will land in the smaller square? Express your answer as a common fraction. So now we can refer back to our formula up here, which is that given a region A inside another region S, we can say that this is region A, and we can say that this big region is region S. The probability that a randomly selected point in S is also in A is given by the area of A over the area of S. So we can figure out the area of region A, divided by the area of region S. What is the area of region A? The area of region A is simply just 4 times 4, which is 16. And then what is the area of region S? It's just 16 times 16. Now, instead of calculating this out, we can use a fast trick where we can simplify. We know that 4 times 4 is 16, so this can cancel with one of these. And now all you're left with is 1 in the denominator, 16 in the numerator, and so therefore our answer is 1 over 16. Not too difficult, but let's now go on to a little bit more of a difficult example. Real numbers x and y are chosen independently and uniformly at random from the interval 0, 1. Which of the following is closest to the probability that x, y, and 1 are the side lengths of an obtuse triangle? So geometric probability will also have a little bit of geometry in it. So how can we figure out that it's an obtuse triangle? Well, we know that first of all, it has to satisfy the triangle inequality theorem. Now, if you don't know what the triangle inequality theorem is, that theorem basically states that x plus y, if the side lengths are a, b, and c, a plus b must always be greater than c, b plus c must always be greater than a, and a plus c must always be greater than b. Okay, so now let's dive into this problem, now that we know that. It is saying that they are chosen independently and uniformly at random from the interval 0, 1. See how we'd have to use geometric probability here, because from the interval means that you can choose any number. 0.093 is part of this interval. And so there's actually an infinite number of cases, which is why we need to use geometric probability for this problem. So it's choosing uniformly at random from the interval 0, 1. So how do we have it so that they're the side lengths of a triangle? We know that from the triangle inequality theorem, x plus y has to be greater than 1, y plus 1 has to be greater than x, and x plus 1 has to be greater than y. So we know these, but now it also has to be the side lengths of not just any triangle, but an obtuse triangle. Now, how do you know that it's an obtuse triangle? What makes a triangle an obtuse triangle? We aren't given any angles, so we can't conclude an obtuse triangle based on angles. But what we can do is look at the side lengths. So what are the 3 different types of triangles? We have an obtuse triangle, we have an acute triangle, and we have a right triangle. Now, an obtuse and acute triangle can have their angles varying. So we don't need to, so let's not focus on those. Let's look at a right triangle. So how does a right triangle look? A right triangle would look something like this. This is a right triangle with a 90-degree angle over here. Now, what do we know about right triangles? Well, the first thing that should come to us whenever we see a right triangle is Pythagorean theorem, which is that a squared plus, if this is a, this is b, and this is c, then that means that a squared plus b squared equals c squared. Okay, so now that we know that, let's look at an obtuse triangle. If we look at an obtuse triangle, let's just draw a very basic obtuse triangle right here. Okay, this is our obtuse triangle with this angle, oh, my apologies, with this angle being greater than 90 degrees. So this angle, we'll call it A. A is greater than 90 degrees. We can see how in this triangle, if this is A and this is B, this length will actually be greater. So actually in this, A squared plus B squared is going to be less than C squared. And so similarly then, in an acute triangle that looks like this, if this is A and B, then A squared plus B squared will be greater than C squared. Okay, so now that we know this, let's tackle this problem. So I'm going to erase all of this now that we know what's going on here. So for it to be in side lengths of an obtuse triangle, then that means that x squared plus y squared is less than 1. So now that we know this, what can we do with this? A good thing with these kinds of geometric probability problems is to always draw an xy graph in the Cartesian coordinate plane. That's really just a simple coordinate plane. So let's draw a coordinate plane here. We don't need to worry about the negative axes because the side length cannot be negative. It's chosen in the interval 0, 1. So this is our coordinate plane. So x plus y has to be greater than 1. So if x plus y has to be greater than 1, let's draw that. That means that y is going to be greater than negative x plus 1. Now, how would you graph this? We know that they're chosen in interval 0, 1, so the total value, or as we would refer to it as, the area of region S is just going to be this 1 by 1 square. Now, for y is greater than negative x plus 1, we can plot that. We know that the 1 means that that 1 is the y-intercept, and since it goes down by negative x, since the slope is negative 1, then the x-intercept will be 1 as well. So, therefore, we can draw this line. Alright, so now that we have that, I'll also draw this on top, just to help us visualize what region S is. So, now that we have this, we know that it'll be all greater than. Y is greater than negative x plus 1, so we'll shade what's above. So, now that we know that, let's look at our next equation. Y plus 1 is greater than x. Then that means that y is greater than negative x plus 1. This is the same equation. And similarly, the next equation, x plus 1 is greater than y, is the same thing, is y is greater than negative x plus 1. So, now that we know that these three are all the same, let's take a look at our next equation. X squared plus y squared is less than 1. So if x squared plus y squared is less than 1, then let's try and think about the x and y intercepts, because there we can figure out an equation. We know that the x-intercept will be when y is equal to 0, so the x-intercept will be 1, and the y-intercept will similarly be 1. But can we really draw a straight line from this? The answer is we can't. So what else can we think about? Does this equation look very similar to maybe even a circular equation? So we know that the formula for the equation of a circle in the coordinate plane is going to be x minus h whole squared plus y minus k whole squared is going to be equal to r squared. This is just a general rule of thumb for the equation of a circle. what we realize is this is actually just the same thing as the equation of a circle, with h and k being 0. So if h and k are 0, I also forgot to mention that h and k is actually going to be the center of the circle. So now that we know that, we realize that this is just going to be a circle centered at 0, 0. So this is going to be centered at 0, 0. And we know then also that its radius is going to be the square root of 1, which is just 1. So its radius is 1. So now this is, I would not want to draw it up here because it would confuse the diagram. But if you wanted to just look at it on a regular coordinate plane, if I just drew a basic one over here, it would really just be a circle like this. With the radius being 1 on all sides and the center being 0, 0. Alright, so now that we know that, we can draw our circle. It does not matter what happens on any of the quadrants 2, 3, and 4 because our two side lengths are chosen in the interval 0, 1, which only deals with quadrant 1 in the coordinate plane. So we can just focus on the quarter arc that's going to be drawn here. So let's draw a quarter arc. And it's saying that it is going to be less than, we know that x squared plus y squared is going to be less than 1. So for example, in our circle that we had here, it would be all the values inside the circle. So now that we know that, we know then that it would be all the values inside this region. What is the common area between these two shaded regions? It is this region over here. So we know that it's going to be this region now. How would we calculate the area of this region? Now it goes back to the formula we learned up here. The area of A divided by the area of S. So we know now that this is going to be the area of this region, which is A, divided by the total area, which is S. Now we actually only need to find A because the area of S is just 1. So dividing by 1 would not make a difference. Now how would we find this? Let's try and find the total area of the quarter circle first. What is that area of the quarter circle going to be? It is just going to be, this is 1 and 1. So the area would just be, the area of the total circle would just be 1 whole squared, which is 1 times pi. So since this is a quarter circle, it would be pi over 4. That is the area of the total quarter circle. But we're not looking for also the quarter circle. We're only looking for this region in the quarter circle. So we have to subtract what comes in this region right here. So we have to subtract that now. So how can we subtract that? That is just a right triangle with legs 1. What is the area of that right triangle? It is the product of the legs over 2. So minus 1/2. That is the area of that region, and then we divide it by the total region, which is just 1. So what can we do here? Let's take a look at the question one more time. It's saying that the side lengths of an obtuse triangle, which of the following is closest to the probability? Meaning that because pi is really an irrational number, so we're just looking for a value that's closest. And we can see that our answer choices are pretty spaced out here. So now let's solve this. We know that this is just going to be 3.14 over 4, which is just going to be 3.14. We can assume pi is 3.14 over 4 minus 1/2 over 1, which is just going to be equal to, well, let's make 3.14 over 4 without decimals. 314 over 400, you multiply by 100 on both sides. You simplify that, get to 157 over 200. And then minus 1/2. 1/2, let's convert that into a denominator with 200, which is equal to minus 100 over 200 over 1. And so when you simplify the numerator, you get 57 over 200 over 1. And over 1 does not matter. So you get 57 over 200. Now, 57 over 200, since we're looking for in decimal form, we know that 57 over 200 we can make it into something over 100 to figure out our decimal form. 200 times 1/2 is 100. So you'd have to multiply this side by 1/2. 57 times 1/2 is just going to be equal to 57 over 2, which is equal to 2 times 2 is 4. 2 times 8 is 16 with a remainder of 1. So this is equal to 28.5. So 28.5 over 100, which is equal to 0.285. We can now look at our option choices, and we see how 0.285 is extremely close to 0.29. And so, therefore, our answer is 0.29, considering that the question was closest to the probability. All right, that will be all for today. Thank you for staying around for this video, and I'll see you in the next one.